Hi and welcome back to another part of mediasoup tutorial series. Let's quickly have a look at what we intend to achieve at the end of this video. If you recall from the previous video, we got rid of most of the buttons and retained two. One for producer, we called it publish, and the other for the consumer, we called it consume. In this video, we are going to get rid of the remaining two buttons. We will make it such that anyone clicking the link to our web page is both a producer and a consumer. If there is only one client, then that client is just a producer. However, as soon as another participant joins, they both produce and consume media to and from the mediasoup server. Let's have a quick look now, shall we? Okay, I'm going to join as the first client. So immediately media starts to stream. Let me change the camera. We have another participant on the other browser. Automatically, the two participants produce and consume. Let's add a third one. And a fourth one. Okay, and we can keep on adding. And we're also going to implement the disconnect. So let me remove this participant. Automatically remove from here. Let me remove this one. Automatically remove from the others. And if I add again, it gets added as a new producer and consumes the other two. So this is actually many-to-many video conference. Okay, so let's go ahead and jump to code. As before, let's start with the HTML file, but first let me copy and paste the file so that we can compare the two. Let us quickly compare the two files, the old code and the new code. There's some style changes in here. Most importantly, you notice that we removed the buttons and applied a few more styles. Okay, so let us now jump to index.js. This is the client code. We are going to introduce the concept of rooms now. So let's go ahead and declare a variable called room name, and we are going to use the path name to get the room. If we don't supply, it will be null and it doesn't matter for now. And soon after we establish a socket connection to the server, let's call a method getLocalStream. And because we are going to consume multiple streams, let's make this an array. Now instead of calling this goConnect, I'm going to call this joinRoom. And then we're going to create the joinRoom method. Let's do that down here. We're going to emit a joinRoom event to the server side. We're going to receive data and it will contain RTP capabilities. Let's print that out, and then we're going to assign the RTP capabilities to a local variable just like before. And once we've done that, we'll go ahead and create device. Now after creating the device, we can go ahead and create transport. So let's look for the create device. Go create transport and change it to create transport directly. This is because everyone joining is a producer. So in this case, we are not determining whether we are a producer or a consumer at this point. We are a producer, and then if there is any other producer on the server side, we will be notified and we're going to consume the media. So let's have a look at the create send transport. Instead of sender, I'm going to change this to consumer and set this to false. The logic behind this is that when we are joining in as a producer, and only if there is a producer already in the room, we'll then create the receive transport, in which case we are going to specify the consumer to be true. Now, as we have seen before, when we produce, there will be an event on the producer transport. An event produced on the producer transport will be triggered. And in there, we want to know if there are any producers already existing on the server side. So this is the produce event that will be triggered. and we need to ask the server if there is any producer existing on the server side. Or rather, we're not asking, the server will let us know if there are any producers. So I'm going to add producer exists. If there are any producers, let us know of who they are. So basically, we'll get their IDs from the server side. If producers exist, then join that room. Okay, let's go ahead and create the getProducers method. Let me do that up here. We're going to ask the server to get us the producer's IDs. And for each of the producer, we're going to create a consumer. You can also write this line in this format. So we basically, for each producer ID, we will call this method and pass in the ID. So let's go ahead and create the signal new consumer transport method. So the signal new consumer transport is nothing but a rename of the create receive transport, and we're going to pass in remote producer ID. Again, we need to change this to consumer and make this true, and the rest stays the same. Okay, so now for the next step, the connect receive transport, we're going to pass in the consumer transport we've just created up here. We're going to pass in the remote producer ID that we've also passed in through this method, and we're going to also include the params ID. This is the server-side consumer transport ID, which we received after the event call to create the WebRTC transport. Let's add our parameters to our connect receive transport method, and let's include them when we make the call to the server side to consume. This now becomes a local variable, and then we append our consumer to the consumer transports array, the consumer transport itself, the server side consumer transport ID, the producer ID, and our consumer object. And then we need to create a new div element for the new consumer media and append that to the video container. But now, because we're adding the remote video elements dynamically, this won't work. So let's comment that out and replace by getting the element by ID, where we provide the remote producer ID and we set the media to that element. And this will also not work because we need to let the server know which consumer ID to resume. You'll notice that we call the getProducers when we join the room, but they may already be producers existing in the room. We need the server to let the existing clients know that there's a new producer that just joined. So let's go ahead and add that piece of code just above the getProducers. So the server will let us know when there's a new producer. We receive the producer ID and then we call the signal new consumer transport and pass in the producer ID. And I guess now the only thing left in the client side is to add the code for when producers close their connections. So let's add that. Let's first comment this out because we don't need them anymore. Let's just delete them. So when a producer is closed, the server will let us know with the producer's ID. So we look for the producer ID in our consumer transports array, and we'll first call the consumer transport.close method and then close the consumer itself. And then we need to remove that consumer transport from the array. So we run the filter and finally remove the video div element from the UI. And I believe that's it for the client code. We can now jump to the server-side code. Okay, let us make a slight change to our routing. And of course, there must be a better way than this. Basically, all I'm doing here is making sure that you provide the path with a room name. If not, then a message to enter a correct URL is displayed. Let's change this variable peers to connections because we will declare peers separately as an object for multiple socket IDs and related data, as we shall see in a moment. Replace all these variables with the following. Let us see what these variables represent. Now, this is the logic that I applied, but one could do a better optimization. With a socket ID, which represents a connected participant or a client, one can get from the peers object the room name, all the IDs for transport producers and consumers created, as well as client's name and whether the client is an admin or not. We shall deal with the admin in a later video. Basically, that will indicate a host or a presenter in a one or a few to many scenario. With this structure, if you have a socket ID, you can get the room name, you can get the router, you can get the transports, you can get the producers, you can get the consumer. If you have a room name, you can get the socket ID, you can get the transports, producers and consumer. If you have a transport, you can get the socket ID, and from the socket ID get the rest. Let us now scroll down and change peers to connections, and don't forget to remove exists producers because we don't need it anymore. Remember, in our client code, we made a call to an event join room soon after we get our local media stream. With this event call, we are going to create a router for our room if it does not already exist. Let's go ahead and create that socket event. I'll edit here. Now create room method does not yet exist, so let's go and create it. If the room doesn't exist, let's create it. So basically, we're just creating a router. If it does exist, let's get a reference to it. And let's get a reference to the peers in our room. And if there's none, we just create an empty array. Although we've already created there an empty array. Let's print out the router ID. Let's add our router and peers object to rooms. And let's return the router. Okay, let's go back to our join room event and finish it. We're going to add the new peer to the peers list. Now we get the router RTP capabilities and send them to the client. So this means we don't need this anymore. Looking at the client again after the join room call, the next call the client makes is when creating WebRTC transport. Now notice here we call this consumer and we're passing in false. Let's jump to server-side code and go straight to create WebRTC transport. Now since we are receiving consumer instead of sender, let's change that to consumer. We then need to get the room name for this peer. Then retrieve the router based on the room name. Now we don't need to check for whether the client is a sender or not. Let's just call the method create WebRTC transport and pass in our router. And we are going to change create WebRTC to return a promise. The first one is a success. We need to return the transport object. If it was successful, then we use our callback to return some params. And then we're going to add the transport to the peers array. Let's go and fix the create WebRTC transport method. We don't need the callback. We're passing in the router, and we're going to wrap the try block with a promise to return a new promise. So in case of an error, we reject. Our try block remains the same. We're just going to remove a few things. We're doing this outside the method. And instead of return, we resolve. Now let's go back up to our event create WebRTC transport. Notice we had included a call to a method called add transport, where we're passing in transport, room name, and consumer to add these into the peers list. Let's go ahead and create the add transport method. First, we add the details to the transports array. And then we add to the peers. Now we know that after the transport is created successfully, we use the callback to return these params. The client receives the params and uses them to create a send transport on the client side, and then listens for connect and produce events after calling the produce event of the send transport. So looking at the connect, when it's raised, it will emit an event call to the server side transport connect. So let's go back to the server code and look for the transport connect. Let's scroll down. Okay, here it is, transport connect. Now we can't call producer transport anymore, so we need to get rid of this, and instead we use a method that we're going to create called getTransport. Pass in the socket ID. It will return a transport. In this case, it will have to be a producer transport, but basically it's a WebRTC transport, and we run the connect method of it. Pass in the DTLS parameters, but we don't have getTransport yet, so we're going to create it. Let's go ahead and do that. So we're going to run a filter against the transports array, and for each transport we're going to check if the socket ID is the same as the one that we've just passed in, and we have to make sure that there's no consumer attached to this transport yet, and then we just need to return the transport. Similar to connect is the call to transport produce, so let's go and have a look there as well. Again, we don't have producer transport. We're going to do the same thing as we've done for the connect. So we'll replace this with the get transport, and everything else stays the same here. Now we have a producer. So let's go ahead and add this producer to the producers array. First, let's get the room name from the peers object by passing in the socket ID. And then let's call a method add producer, but we need to create this method, or make sure to declare it properly. Let's go ahead and add the add producer method. Let's do it right here. So we've added the add producer method, and then we will notify the client if there are any producers already existing, because remember, this client is just joining and is joining as a producer, so we're just checking if there are producers already existing in the room, and we have already implemented the producers exist in the client side. Now if producers exist, we call the method getProducers. So we've already created that method, and we are emitting a socket event getProducers from the server side. We have to go and create this getProducers in the server code. So let's just go there. Okay, let's go ahead and create the getProducers event. Let's add it here. Now we are going to loop through the producers list after retrieving the room name this client belongs to. And basically we are looking for producers in the current room excluding the client that is making this call. And then we're using the callback and return the producers list. And when the client receives the producer list, we loop through that list. And for each producer, we call the method signal new consumer transport. Notice now, for each, we are going to create consumer transport, and the journey as a consumer starts from here, as well as when the client is notified when a new producer just joined. Okay, let's have a quick look at the signal new consumer transport method. Everything is the same. Let's go down to connect receive transport method, and here we emit a consume event and sending RTP capabilities, remote producer ID and server consumer transport, which we pass when we are calling the connect receive transport method. Let's jump to server code and update our consume event. We need to add these two, remote producer ID and the server consumer transport ID. We need to get the room name, we need to get the router for this room, and we need to get the consumer transport. When the producer closes, we need to let the client know that this producer has closed. So we need to close the consumer transport. Then we need to remove the consumer from the list. And just like the producer, we need to add our new consumer to the list of consumers. Let's also return the consumer ID to the client. Okay, let's go ahead and add the add consumer method. Let's do it right here. So we first add the consumer to the consumers list, and then add the consumer ID to the peers list. Now jumping back to the client, we notice at the end of the method, we are making a call to the consumer resume event. So let's jump back to the server-side code and update our event. Now we need to get the consumer object from the consumers list. And when we look at the connect event of the consumer transport, we see that we are making a call to the transport receive connect event. So let's go back to the server-side code where we also need to update that event. We need to get the consumer transport object before we can make connect method call. Let's go and fix a few things that I think I forgot to include. Let's jump to consumer resume. We need to pass in the server consumer ID. And also in the consume event, we are receiving the remote producer ID. So we need to change this to remote producer ID and this one too. But before removing the consumer from the consumers list, let's close it. And one more place, producer ID. Now our consume event is complete. Oh, one more place we need to make a change is make sure to declare it as const. And in the transport receive connect, we need to add the server consumer ID transport, getting it from the client side. Now let's go quickly to the transport produce right here. Once our producer is created, let's inform the other clients know that we've just joined as producer so that they can consume our media. Let's call a method called inform consumers and pass in room name, socket ID, and producer ID. Let's go ahead and create this method. Let's do it right here. Let's just print out the ID, room name, and socket ID. For each producer, we first confirm the producer is in the same room as the clients. Let's get the producer socket and use the socket to send producer ID to the producer. And then let's emit a new producer event and send the producer ID. So basically the new producer is sending its ID to all the other producers to consume its media. Okay, so the only thing left now is the disconnect event. We need to update there so that we can remove consumers, producers, and transports when that happens. So when a peer disconnects, we need to remove all its consumers, all its producers, and all its transports. Also, we need to remove the client from the peers and remove from the rooms. Now we haven't created the room items. Let's go ahead and add it here. We need to close the item, whether it's a consumer or a producer or transport, and then remove it from the list and return our new list. Let's do final touches. Okay, we don't need the async here, and that's it. Okay, let's go and test. Let's run our server. Okay, so we're not passing in a room. Let's press enter and see what happens. Okay, so it's telling us you need to specify a room name in the path. Okay, let us now enter room 1 and press enter. Okay, now we see a video. Let's open Safari and copy this URL. Press enter, allow. Let's open another Chrome tab. Okay, let's close one by one. Close Safari. So I'm now going to try and access the application from another computer. Press enter. Okay, let's change the camera. Press enter. Okay, it seems to be working, but you see there's no frames or media being received from the server side. And the reason for this is, let's go back to the code. The reason for this is because of the server. All we need to do is change the 127.0.0.1 to our computer's IP address that is running the mediasoup server, and the server has restarted. So let's go back to the other computer and try it out. Press enter. It's only one producer. Change the camera. Press enter. Now the two are both producers and consumers. Let's try the third one, and let's try the fourth one. Okay, so it seems to be working pretty fine. And let's try to add another one from my iPad. Okay, so it seems to fail, but there is a reason for this. Now here we have 4 clients joining, and the iPad is the 5th one. So we have 5 participants. Each one has got 1 producer transport and 4 consumer transport. Those are 5 for each participant, for each client, basically. There are 5 clients. That means there's a total of 25 transports. Let's jump back to code. And if we go up to the code where we are specifying the RTC minimum and maximum ports, you notice that we have a maximum of 20 ports, but we need 25. But unfortunately, I've restricted my Docker container to expose only this range from 2000 to 2020. So I will not be able to increase the number of ports here, but let's transfer the code to the other computer, and there I will be able to increase the number of ports, and we shall test for more participants. Okay, I have transferred the code from my Mac to the Windows computer. Now I may be tempted to change this to the IP address of the Windows computer, but now I'm not running in a Docker container. I'm running it directly from the host machine. So this will also not work. What we need to do is remove the announced IP and replace the zeros with our computer's IP address. Let's run our application. So our application is running. Let's go ahead and try again. Okay, so our application is running fine, but now we need to increase the number of ports. So let's go back up. Okay, let's make it 100 ports. So now we should be able to add more participants, as many as the number of ports allow. Let's refresh this. I'm going to run from the iPad. Okay, so that's the iPad, and I'm going to open from the Mac. Let's open another one, Chrome maybe. Let's do another one. and one more. As you can see, we have 1, 2, 3, 4, 5, and 6 participants. And that concludes this video in the series. Hope to see you in the next one. Bye. So now I have 1, 2, 3, 4, 5, 6, 7 participants.